So hey guys, in last video we have built this interesting application, which is a Google Translator kind of application, where we can simply go ahead and translate our sentence from one language to another language. Okay, so if any of you haven't watched my previous video, I will give in up the link of that video in above I button. Take it so that you can go ahead and watch that video. If you haven't, that's totally fine. uh, because I will be explaining everything from scratch for building for learning LangChain. Okay, for now I will just in this video we will create a simple RAG application. A simple RAG application contain a few things, like you can check it out here, RAG LangChain. तो बेसिकली इसके थ्री सिंपल आर्किटेक्चर होते हैं, जिसे जैसा कि आपको इसको नेम से आप समझ पा रहे हो कि नहीं, मैं आपको समझाता हूँ. I don't usually create animations and all. I just go and take it from Google Image. Credit will surely be given to the guy that who created the image. I will not take the credit. Let's take a simple RAG architecture so that I can explain it very easily to you. So basically, we have this. Let's take this example, okay, which is from official by the LangChain website. So that's fine. So it RAG completely have three part: retrieval augmented generation. Okay, so its name say everything about its own. Retrieval means whatever we have the data, we will retrieve it from the website or any data or any PDF document. And after retrieval, the query which user will be asking will be given to the vector embedder, will which will convert the wordings and sentence into the vector embeddings, and then try to fetch the similar things from the vector store, and then it will be passed to the our model. Our model will then get that raw information, raw data that we have fetched from the database vector store. It will be just rephrase it for the human understanding, so that it will be easily understood by the human. So let's not worry too much about the terms and terminology. We will go ahead and we will look into everything, that what each word suggests, like retrieval, augmented, and generation. I will go ahead and will try to explain you so much better. Okay. So before we moving on to this, I will encourage you to open your Windsurf or VS Code, whatever the text editor you are using. It doesn't matter. So first, what you will do, in here I will create a folder, rag, simple rag app. Okay, and now I will just go ahead and create a simple file, ipynb. Okay, nice. And after that, what was our next step? We will we will go ahead and select our kernel, which is llmvnb.python. Okay, and we will just check if everything is working or not. Nice. So everything is working fine. Our notebook is running and all. So I will just, for example, I will just go ahead and type a markdown for decoration purpose. Okay. Simple rag application. Okay. And this is our markdown. In last video, in second last video, I've told you there are multiple ways to mark down. Like you have multiple ways. You can create like this heading, like this h1 tag, this is h2 tag, h3 tag. So you can simply let me tell you all the story about mouse and Lori. Yeah. तो अगर मैं इसको रन करूं, so you can what is happening? Yeah. So you can check, like the font size has been changed. So that's what this hashtag do. So I will just remove this and let it be like it was previously. Okay. So what is our first step? A retrieval. So what we are going to train our model for? So let me tell you a simple thing. I will just go ahead and take uh, just look into these guys. You will understand everything. Okay. Once I will done, you will get everything so much clear. LLM chat Grok. Okay. And model will be, I will just simply pick the model Llama. I don't remember the name. So I will take from what was the name? Versatile. Okay. Uh, you can you can choose any model you want. I grow from the Grok playground. There are multiple model you can choose. For the simplicity purpose, I have chosen a simple model, which is this. Okay, you can also go ahead with this instant and all, which is trained on 8 billion parameters, 70 billion parameters. You can also check the pricing of this thing. So we have free tokens to use, some limited tokens for the experimental purpose, but that's fine for us for the video. Okay, so I will take this model. Okay, I will copy, I replace. So why we choose the model? So there are multiple criteria that we have to go through to take a best model for our application. So for now, you can check. You can simply Google it. What are the multiple criteria to pick the best model? Okay, metrics like there are several metric performance metrics, and there are multiple things like token is also very necessary. Like for example, if I take a simple like instant model, so it has a very less context window size. Context window means um, it will when it parses the sentence, lose it will have just smaller window where it can parse the sentence and word to take a more accurate context uh, of the meaning of the word. Okay, I hope you understand. But if we have more context window, okay, like 128,000, so we can paste a lot of text to our inputs, and it will just work fine. Sometimes you must have seen like in chat gpt, if we paste a lot of bunch of like in lakhs of character of content, sometimes it's given error that uh, there are overloaded character error and some kind of error that is given. Okay, but if we have it, Google has like ChatGPT has improved so much, so it increases their token context window so that we can now paste a lot of content at once and it will just work fine, and processing everything, it will just work like normal. Okay, so for this example, I picked this model. Okay, which has a uh, context window size. If you want to check, you can check it. We can check it on Hugging Face. Llama models are versatile was this context size. Okay. So it has a context size of 128K, 128,000 token we can paste into our input and it will work fine. If we go above that, it will surely give us an error. Okay, so that's what we have to take care of. Okay, for just lot for now we will not worry so much about it. So why we use simple RAG application? Why when we build RAG application, why not we just simply take the query, like whatever the question which is asked from the user, what is abacus, and paste it into our and send it to our LLM to work a question, not string. Okay, and print the response. Okay, so why not we API key? So this, why it doesn't take the env variable? So we have this. This is a common problem. We for loading the env we have to take a package, take a module which is .env, which is if you have if you have watched my last videos, so we have this requirement file where all the packages that we need for this video we have all right here. Okay, and for future purpose, if we need another packages, I will type it here and we'll install it later on. Okay, so we have .env, so we will import from .env, import load .env, and what it just simply do, it load whatever variables are in .env file. Okay, and if I let's take this out from here and execute true, and I will take another cell and we will paste our cutted text and will run. Now it will run just fine. Yeah, so content abacus is ancient calculating tool and whatnot. Okay, so this is our a lengthy response. So why we use rag here? Why not we can ask anything like in my browser we have open a page. I think what was the page? Let me take a link of from my. So we have this website which from here we will ask a question, like we have what is task decomposition. So what I will do, I will ask this question to this LLM and let's see what it gives. What is task decomposition? Okay, break down complex tasks into manageable component tasks. Problem solicited involve breaking down complex problem into smaller, more manageable component. No doubt it can be a truly answer, but not as much accurate that this document will provide. So, like, why we need RAG is we need a accurate and accurate result. Okay, so the problem with this LLM is like it has been trained with the um, it has pre-trained LLM model, you know. So we don't know if the model has been trained with this kind of information. It can just give us any kind of information. Like we can ask anything like what is paracetamol, cetamol, okay, and it will give anything. Like I'm not saying like it will not give an answer. It can give an answer, but sometimes it will hallucinate. What is hallucination? If we ask any question that the model don't know anything about, so it will just try to um, it will try to I mean manipulate you. It will just give you any answer, and it will say like it has been given by the model, so it must be correct. But that's not happen every time. uh, the LLMs can give us a falsy response, so we have to take care of it. And that's where RAG comes into the picture to um, to save it from this hallucination and problem. So RAG not only just provide a hallucination safety, it also gives us our insurity that whatever the response that LLM is giving to us has been taken from a reliable source. Like for example, we have taken this content from here, and we will train our model, not train our model, we will store the whatever the text in here, and whatever we will ask will be just taken from this content. Okay, whatever we will ask from this context, from this block context, it will just pick the answer from here, not from our pretend data. If it is not found in their rag, I mean vector data, it can send us any response we need. Okay, hope you got the point. So that's why we train the data. And for reliable response we need to um, store this text. Okay, so how we will do that? So that's where this comes into the picture, the thing which is the retrieval. Okay, retrieval. Okay, retrieval phase. So in this phase what happen, we retrieve the data from the source. What the source can be anything from any website, from the PDF document, for any text document. In further video we will see a lot of videos where we will build an application which will be which we will use to embed a lot of text from the PDF, from website, from many sources. We just need to store the data. We store the data. So there is this thing, our model do not understand the text. Okay, so that's why it store everything in the numerical representation. Okay, and what the numerical representation of, what can be the numerical representation, you must have this question in your mind. Okay, so that's where the vectorization comes into the picture. Okay, so vectorization what do, it just spread your word onto the plane. Okay, and embeddings is basically the semantic meaning, whatever that word gives us the meaning, it will spread on the plane. uh, let me show you vector embeddings by example. So you can see here, like see, so here if you are, if this is visible to you all, let me open this website. So you can see like this spread the word into the 3D plane. Okay, 3D plane. So this this picture was so much clear, it is not opening. So you can just simply see, like this is object 1, object 2, object 3. These objects are nothing but your word. Okay, and this is our embedding model which will convert this sentence or word into numerical representation. So this is 3D plane, it will be placed anywhere. Like if two words are similar, it will be like they will those two words will be like very close to each other. Okay, so that's how vector embedding are. And you can see here, embedding model convert this into vector representation. Okay, so we will see this practically, not theoretically. So let's do this thing. Okay, let's do the retrieval phase. So for that purpose we need a few things. We need to retrieve the data from this website. So what, how we will do that? If you have a programming experience, you must heard of beautiful soup. Okay, this is very interesting library, we can use it for scraping the data from the website. But langchain from their framework, it provides us a very beautiful, not beautiful, very useful package, um which is a LangChain community document loader, import web-based loader. Okay, and for using this function, we also need a beautiful soup. So we will import beautiful soup bs4. Okay, and what next? So we will create a loader and web-based loader. Okay, so it has a few parameters to given. Okay, so first, like, will be a path, web path. First thing, here we will give our URL what we want to scrap. Okay, and for next we have this ps box. What is it? It's simply accept a dictionary. Okay, whatever the parameter, whatever what we want to scrape from the website, their classes and their IDs, we can pick and paste it here so that it can scrape that scrape the content of that element. Okay, you will see everything. So we have this thing, just that's it, and we will just paste our URL and all. We will just copy it and paste the web path. Okay, it is we can paste multiple paths, but for now I am just taking this path. Okay, and for here Let me zoom a little bit. And here what we will do, parse only. It is not suggesting it. Let's test if this package is installed or not. If I run this, yeah, so everything is working. We have this package in our um, environment, so we can, okay, dictionary, and I will simply go ahead and type parse only. Okay, it will only parse this thing, bs4 dot and sub strainer. It is function of, let me format this. Okay, cool. Now it is fine. So now we have this strainer. In this trainer, we will give the classes for what we from what we want to scrape the data from. Okay, and it will just take a tuple where if we go ahead and inspect a little bit from here, we can we can check this thing, that thing that we want to scrap the data from. Okay, we also want to scrap the header, and we also want header. Okay, we can take the data from the post single as well, but there are multiple unnecessary thing like table of content. That thing will be taken. I don't want that junks in my text. So I will, for now I will just take post content, and okay, post content header, post title. So I want to scrap post title, post content. That's it. That's post title, post content, and that's it. That is what I want to scrap for now. And we can also scrap this. Okay, we can scrap this post header as well. So I will post title, post content. Let's take post header as well. It contain the author and all. So I want to I want everything to be scrapped. Okay, so now we have this loader um here. Org is fine, and if we talk loader dot load, is this invalid URL as no schema supplied? Perhaps you meant HTTPS. Just cut it here for to make it more clean. Scrap URL. So scrap. Okay. Oh yeah. So it will be tuple. Remember I told you it can take multiple URL. So now I think let me take something. Stack everything. Let's take this example from, okay. So I copy from a previous one of my project. I copy and paste it here, and copy and paste is a very important tool to use. I hope you understand it. Okay, so this is our script URL. I may have done something. This is not a valid. Okay, so hope you understand. This is our loader is ready, and when we'll do go ahead on here load. Okay, and we will load. It will scrap everything. What is it? Missing schema. So what was the issue? I don't get it. Was it expecting a comma? Okay. Yeah. So it hasn't scraped anything because we have given a wrong class. We have this. We have a hyphen here. Okay. And when we run this, so you can see we are getting the data. Okay. So we are getting our data from. But what is this? What is this document we are getting? Mhm. So in LLM, like in LangChain, we have a, a very important data structure, which is a document which we use to we when we pass our embedding model to LLM, it expect the document. This vector store expect this document data structure to convert it to the numerical representation. Okay, that's why we need document. Okay, so we can now we have our data. So that is our retrieval phase. Okay, now we have our data. We can proceed with our next phase, which is splitting it. So we you can see this is pretty long data. Okay, let me see how much video is long. It is already 28-minute video. It will not take a very long time now. Okay, so now since we have now data we have right with us, we will chunk it, chunk the data. Okay, and for chunking, what we will do, we will split the data and uh, we'll split the data and create embeddings of it. Okay, so for that purpose what we can use, we have a package from LangChain as well for this purpose to achieve this thing from LangChain. Okay, from LangChain dot text splitter import recursive character text splitter. Okay, and what it will do, we'll see. So we have text splitter, recursive text splitter, chunk size. Okay, for now, for this video purpose, I will take 1000 and chunk overlap. I will 200 words of overlap. Okay, so why we overlap the chunks? Why we overlap the content? So for example, let me explain it to you. Like for example, Thor love pizza, samosa, and jalebi. Okay, and Aaron or also likes to travel in, in Bangalore. Okay, so when we split it for here, like we have 1000 word, but let's say origin size is 5. I'm explaining you. Okay, 5 and overlap is 0. Overlap is 0 for now. Let's suppose. So what it will do? This function will take this 5 character, 3 5 character 1 2 3 4 5. okay, and split it and store it into an array. Then again it will from here start, it will take five characters, 1 2 3 4 5. It will store like this: Thor. The first chunk will be Thor and space. Second will be space love, love, okay. And third will be like here, 1 2 3 4 5. Okay, fine. So that's how this chunking works. But if we do a overlapping, like let's say three characters, so what it will do, it will overlap. Like if here 1 2 3 4 5 space, then it will start from previous, okay, from previous three. So it will start from like it ends here, like 1 2 3. It will start from here, space, okay. Hope you are getting the point, guys. Space P, 1 2 3 4 I. So this is how it will work. Then again it will start from here. It will take three character back and then take up further. Like here PI JZ. Okay. So it is what it is taking. It is overlapping from the content. You can also Google it. Um, Chunk overlapping. You can usually go ahead on Google and try to understand everything. Okay. So you can get the idea from here. This is our this is our sentence, and this is our first chunk. This is our second chunk, but it overlap our first chunk, okay, two chunks up. So why this is really important for the application? Because if we do not overlap the words, so it will lose the context. What is context? The meaning, like how the previous, like if we write the English, um, every word is related to its previous word, okay. But if we do not overlap, it will lose the meaning, like why we use distinct approach, for what we use distinct approach. So so we know if we read a back, we have these human inputs. So that's why we use distinct approach. You got the idea, okay. So that's why we use this chunk overlapping to maintain a context, okay, for what the wording, for what the sentence is all about, okay. So that's why we use the chunking, okay. So now we have the text splitter. We will split it, text splitter, our document. So it will take, it will not split documents. And it is all on the website. LangChain text splitter. You can just you can go ahead on the website and see the example by yourself, okay. You can read the documentation, it is really very good. So here it is, chunk size overlap 0, and how it produce the chunking and all. So we have splits, and now when I print it, split documents should be, so we have a lot of, see, so we have this amount of chunks, thousands chunks we have, okay. I mean, document we have this. I don't know what is the length. We can easily check the length. 63. So it has been broken into 63 document, okay. So now we have our splits. So what the next step? We have our retrieved data, we have split it. Now we will embed it, okay. Create vector embeddings. Why didn't we create vector embeddings from all this thing? So we can do this, there is no problem. But the better we chunk our data, the more context we provide to our LLM model, the better it will understand it and will give us a more more clear and concise result. Okay, we can easily go ahead. You can try this by yourself. You can take the text and create a vector embeddings, but the embedding models has their own um, significance, their own ability to create embeddings from the context. The embedding model has also the context size. They cannot take any length of the input and convert the vector embeddings for it. This is very important that we choose the vector embedding model. So for now, for uh, for this video, I will take a vector embedding model from the Hugging Face. Okay, we will use simple. I mean, um, so um, we can use any vector embedding model, sentence transformer, Hugging Face. It doesn't matter. You can take any vector embedding. We are we are very close to close this video. We are very close to create our application. Okay, sentence transformer. Hugging Face. We have this thing. We can take it from here, not here. This we can convert into the cell, change cell to code. Okay, and now we paste it here. So it is working. So our embedding model, Hugging Face model, we can pick any Hugging Face model. So here it has taken this. Okay, sentence from embed paste percent 2. So I will take the same, and we have our embedding model, and but our what where it will store our data. Okay, so let's test this first. Yeah, so it will take a little bit time. It will download the model. So until it is downloading, we will move further with our code. So we also need a chroma db. Chroma db is what it will store our. It is a vector store, which will store the vector embeddings in the memory. Okay, so you can it LangChain also provides it. LangChain vector store. There are a lot of resources you can use, but I will for simplicity purpose I will take Chroma. Okay, it is in memory vector store. We will store the vector embeddings in our memory in our RAM. Okay, so you can see here. mm, we will take the Chroma from vector store. It is online. We don't want this. Mm, vector store. Language. Language. So let me take it from my one of my previous, and it is taking a time. It is downloading the model. Um, so this is vector store Chroma, which will provide it. Okay, and we cannot run this since the previous cell is still running. But once it is done, we can go move ahead with this thing. Okay, So guys, I'm going to interrupt this. It is taking very long time. Why not we can use a simple model from Gemini? Okay, so we can also use Gemini model. So for we have Gemini, I have Gemini key. So I will take it one of my project. Okay, you can create your own API key. It doesn't take too much cost. Okay, I will hide it. So I pasted the Gemini key in my ENB, and I will take the example. Okay, from one of my uh, this is what. So you can check it here. One of my project, I will take it and paste it here. Okay, this block I take it from my one of my project. Okay, so if we run it, okay, we have splits embedding model, which is I take it from Google, which is Google Gemini embedding model. Okay, and it is already 41 minutes. So don't worry, we have very close on phone. So we have to rerun this because we have put a new env into our application. So now we will run it. It should work like a charm. The thing that why I'm not using the Hugging Face model, it will download, it will take a little bit time. Okay, so I'm using a Google generative AI embedding, but you can use it. You can try it. You can try this out. Okay, you just replace this line with Hugging Face model and the embedding model's name here. Okay, and it will work fine. So we have vector stored created from this split. Okay, now if I go ahead and create a retriever. Okay, so we are halfway done. I will create a retriever. We have our retriever setup. So now if I print retriever dot get relevant document, what is class decomposition, if we print, so it will just go, and from embeddings it will try to fetch the data from for us. Okay, which will match this aside which we scrapped. Okay, so you will see it is taking a lot of time. Maybe I will have to end this video and create another video. So you can see it has done and give us document which is about task documentation can be done by LLM, simple prompting like steps and all. So guys, our retriever phase has been done. Okay, next video we will see how we can augment our response and generate a human readable response, how we can generate a human readable response. Okay, so in next video we will see the generation and augmentation phase. And so see you in the next video. If you have liked this video, don't forget to hit the like button. This will encourage me a lot to create a video. Okay, so let's meet in the next video. Tab tak ke liye, bye bye.